Okay, we're back in section 9.1. This time we're going to focus on the p-values and significance level. P-value is basically your evidence. It's the number that we're going to assign to your evidence, and that's going to help us to make that conclusion of whether we're going to reject or fail to reject the null hypothesis. The significance level is basically the barrier that we're giving ourselves. It's kind of our measuring stick. So if the p-value is low, we're going to reject the HO. You have convincing evidence for HA. So try to think of that rhyme. P-value is low, reject the HO. The p-value is lower than what we are setting for our alpha, our significance level. Then we reject the null hypothesis, saying that we have evidence for the alternative. If the p-value is high, we will fail to reject the HO. We do not have convincing evidence for HA. Again, going back to our analysis or a comparison to court trials, if we have enough evidence to suggest somebody is guilty, that is when we find them guilty. If we don't have enough evidence, then we just simply say that they're not guilty. We haven't been able to prove their guilt. When the p-value is less than the alpha level, we have statistically significant evidence to reject our HO. Now the alpha level must be set at the same time you write the hypotheses, before you conduct the study or gather data. And the outset of this whole thing, we set up our framework. We set up our hypotheses, we set up what alpha level, what significance level we're going to be judging this against. Just like again, when we go to the court trial, we get there and we find out this person is being convicted of this, meaning we're trying to build evidence to prove this person is guilty on this act. Then you're told, like in a murder trial, can you prove it without a reasonable doubt or beyond a reasonable doubt? They're setting your alpha level, your significance level, so it's so low there's no chance that this just happened by pure chance alone, that this person must have done something. So we're going to look first at our study from the Jordanian children again. So the sample mean hemoglobin level was 11.3 and the sample standard deviation was 1.6. A significance test yields a p-value of 0.0016. If an alpha level of 0.05 was set, what would your conclusion be? Now we'll go through how to find those calculations and how to run all that stuff in the later sections, but for now we're just purely making our decision. And we're making our decision based on our p-value being evaluated at that alpha level. Now remember we said if the p-value is low, you reject the HO. If the p-value is high, you fail to reject the HO. So our p-value of 0.0016 is below our alpha level of 0.05. That means that we have enough evidence to say that with this low p-value, we are going to reject the HO, and we have convincing evidence that our HA is true. So to write this up, we would say with the low p-value of 0.0016, we reject our HO in favor of HA. Thus, we have statistically significant evidence to suggest the true mean amount of hemoglobin in Jordanian children is less than 12 grams per deciliter. Now notice this word in here, statistically significant. We use the word significant in our normal everyday use of the language to mean more of important. But the word statistically significant has special meaning in statistics, just like the word normal had a special meaning in statistics. So you're only calling something statistically significant if your p-value is lower than the alpha level that was set. One more example of this. For Yvonne's survey, 96 students in the sample said they rarely or never argue with friends. A significance test yields a p-value of 0.0291. What conclusion would you make if alpha is equal to 0.01? Again, we make our conclusion based on our p-value being measured against our alpha level. In this case, our p-value is higher than our alpha level. So if the p-value is high, you fail to reject the HO. You do not have convincing evidence for HA. So in this case, we would write that up as with a p-value of 0.0291, which is higher than our alpha level of 1%, we failed to reject HO in favor of HA. Therefore, we do not have statistically significant evidence to suggest the true proportion of teens in Yvonne's school who rarely or never argue with their friends is not equal to 72%. Sorry, you cannot see that. Let me adjust that for you. Notice in both of these conclusions, we first just wrote our conclusion in terms of their p-value and alpha level, language that most statisticians should be able to understand. But we went on to interpret that in context of the problem. Make sure you're always including both parts in your conclusion. Your conclusion is based basically on symbols and numbers, and then translating it to be in everyday speak so most people, the general public, should be able to understand it once you've interpreted it in context of the problem. Thank you.